Hi, welcome back to my MVA course called Building Recommendation Systems in Azure. We now have reached the third module of this course called Collaborative Filtering, Association Rules in R and Azure ML. What we are going to cover in this module is first some basics, some theory, all regarding association rules, and then going more into the demo part. First, we start off with RStudio, going through one certain R script, and then in the second part of the demo, we are going to look into how to integrate our R script into Azure Machine Learning. Similar to the previous module, we are going to deal with the dataset provided by the AdventureWorks database. Or, well, let's put it this way, we are actually taking a dataset that derives from that AdventureWorks database, but yeah, more focused, more for our demo scenario. So let's get started with association rules. This is all part of the area of market basket analysis. So you can imagine here in market basket analysis, what we are interested in is, okay, the customer has put certain items into his or her basket. What else could the customer actually be interested in? So it's all about the customer purchasing behavior. And it's based on the theory thinking that, well, given that customer A has already bought items A, B, C, and D, and there was another customer who has actually bought A, B, C, and D as well, and on top has bought item E as well, this is something that could be recommended to our original customer as well. So the whole point of this, or what is the business objective behind it? Obviously increasing sales and maintain inventory. So if you run your own company or if you run your own shop, you obviously want to know, okay, which items you need to actually buy in advance as well, so that all the customers who want to buy this will be easily satisfied. Whereas if you don't have it in stock and there's a lot of demand, then obviously it's not really that great as a shop owner. So let's get started with the association rules and back to our kids with the fruits. So all of those kids actually have their own preferences in terms of fruit. And here we have the final kid, the third one from the left, who really likes bananas. So let's so this is all somewhat well, not confusing, not necessarily modeled up, but the whole point of association rules is actually putting this in a form of a matrix. So here we have those four kids where we've ordered which fruits they actually like. And then finally, it's all about the final kid. What does he actually like to have? Based on the, well, we already know that he really likes eating bananas. What else could we actually recommend to him? And based on another kid or another boy who takes bananas and cherries as well, then here in this case we could suggest or we could recommend cherries. This is actually what association rules makes it to collaborative filtering. The association rules basically just means that what you've seen on the left-hand side is transformed to a matrix form. And these are association rules, and then based on those rules, we can apply collaborative filtering and therefore suggest something to this last boy. So before we actually dig into the demo, let's get some terminology right, or let's get this settled first. So first we start off with items. Here in this case we have lots of fruits. All those fruits are items in itself. Then there's another term called item set, or another word, set of items. So as it says in the word itself, it's any subset of all the items that are listed up there. So it could be a set of 2, could be a set of 3, could be a set of just 1 actually, or a set of all the items as well. The next very important term here is transaction. So a transaction is an item set as well, but an item set that has actually occurred amongst our customer base. So here in this case, we have a very small customer base. So this is something that I would not recommend doing your recommendations on. But still, let's keep it as simple as possible. We have those 4 kids, and therefore we have 4 transactions. The first kid really liked lemons and mangoes. The second one, red berries and oranges, and so on and so forth. So you see, there is no certain order at all. It's just a collection of items. Then the next important term is a rule. So with a rule, it's something like if blah, 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 then blah, blah. So you see that there is some causality. So in this case, we don't actually have a rule listed amongst our customers, but let's just take one rule. For instance, taking the last kid, she really likes grapes as well as apples. And we can make it a rule of, well, since she likes grapes, therefore she also bought apples, or she also ate apples. It could also be taken the other way around, but you can see with a rule, the order is important. Another important aspect to note here is that with a rule, it's not necessarily just 2 items, which is here in this case. We could also take a rule, given that someone really likes bananas and apples, therefore, so you can see the first 2 items, apples and bananas, therefore, this person also likes grapes. So the causality, the right-hand side of the rule would then be grapes in this case, yeah. And then based on those rules, I mean, it could be possible that only 1 kid amongst 1 million actually follows this particular rule. So it's not really that relevant. So we need to measure all those rules according to their relevance, as well as, well, later on, confidence as well, like how likely is this actually going to take place. So relevance here meaning how often does a certain transaction actually happen. So here, again, the support is towards an item set or a transaction, not a rule. So it doesn't really matter what order, as long as certain items are actually being covered. So here I wrote proportion of transactions containing a given item set. Here in this case, it's not really that great to see because we have a very small data set of transactions. In fact, we actually have only 4 transactions because we have those 4 kids. So all of those transactions have a support of a quarter, meaning 25%. The next important measure is a confidence of a rule. So yeah, here you can see the formula. In other words, it's just a measure of trustworthiness associated with each discovered pattern. So in other words, so you see with a rule, there's a left-hand side, here in this case, grapes, and a right-hand side, here in this case, apples. So given that people take grapes, what is the probability that all those people are going to take apples as well, or like apples, or buy apples, or whatever you like to use? So let's dig into a demo, and there you can actually see all those values as well. In this demo, we will start off with RStudio, and then later on, we are going to integrate the R script into Azure ML or into an experiment in Azure Machine Learning. So I've opened RStudio and already can see the script that I'm going to go through step by step with you as well as the console. Let's first set the working directory because we can see that we are going to read 2 files, CSV files in fact, but they are not listed here in my file, workspace, or environment. So all those things are actually saved in this folder, and I want to set it as my working directory. So I'll just go on set as working directory. Then I can actually start reading those sets. So we can see data set 1. I can actually have a look what it actually is in there. So it's a very small one. It's just, well, a set of 2 items being frequently bought together in this case. Another one is items basket. Let's have a look at this one. This is just a matrix of items being bought together. So we don't actually see how often it actually happens. We don't actually see a rule either. But these are all rules that can be or that will be calculated later on using some library. And as I've already mentioned libraries, so these libraries are actually being used. Before I actually use those libraries, these library packages need to be installed. So how I do that is I go to packages and then click on install. I can just look for A rules and they are already listed here. And obviously I want to install the dependencies as well. Installing. And so, okay, I've installed A rules. So this is the library for R Studio, for R in general, especially for a priori algorithms that are being used so that first we can read all those transactions, so seeing all those items together in one collection, and then deduct or infer rules out of these ones as well, out of the transactions. The next one, A rules viz, is just a library to visualize all those rules or those transactions as well. This one needs to be installed as well, so I'll do the same thing as beforehand and see this in this drop-down list as well. I install it, and yes, done. So okay, now I've installed those ones, but I need to specify in the console that I'm actually going to use those libraries as well. So loading those ones and the next one as well. So now I want to get some description of the transactions. So here. And this is just easily done by reading the transactions from a given CSV file using basket analysis, and the separation is a comma. So since it's a CSV file. So I'll just do that. And we can see here on the right-hand side, okay, a large transactions. It has actually quite a few elements, but we can have a closer look what it actually has. So we see more than 20,000 transactions, so these are the number of rows as well, and 46 items. So remember, items are back in the fruit example. These are the number of fruits that are available. So here in this case, these are all sorts of like bike models or bike accessories and so on and so forth. Transactions here in this case are just collection subsets of all those 46 items as well. We can have a look at a summary as well, and let's just do this. So here we see the same information as beforehand. We see the most frequent items as well, which are Sport 100, water bottles, and so on and so forth. Yeah, and gives you some more statistical information as well. Going back to the script, actually, we now want to just plot how frequent certain items are, and this is why we are importing the library A rules viz, so that we can plot it. And then you can see here on the right-hand side, or in the plot side, and yeah, obviously a frequency plot or a histogram pretty much, and you recall the most popular ones, Spot 100, water bottle, patch kit, and so on and so forth. So this was actually just data discovery, or seeing what our CSV file actually gives us. Now we want to actually create those rules. because, okay, first we had those transactions, and these were more than 20,000 of them, and this is because, well, we have more than 20,000 customers in here. Now, based on all those transactions, can we infer some rules? And we don't have to actually calculate it. This is why there's in our package the A rules as well. Let's just use or run the first one. We can see a priori, so we are running the a priori algorithms. We are setting obviously the transactions that have been read beforehand, and we actually only want to see have a list of all the rules that have a support of more than 0.1%, support of more than 0.1%, and a confidence of 80%. Meaning, okay, the rules with a confidence of 80% means based on given on the left-hand side, 80% of the people would actually buy the right-hand side as well. So the rules have now been calculated actually. Let's have a closer look what it actually says. So here we can see a parameter specification. Yeah, we did say we want to have a confidence of at least 80%. A support of at least 0.1 or 0.1% as well, and so on and so forth. If we so in the next step, we want to sort the rules, sort them by decreasing confidence. So okay, so sorted, and we can have a closer look at the rules by inspecting them. Inspecting the rules actually pretty much just lists all those. Or the rules, and we can see, okay, there are about 219 rules. We can see the last one, that the one with the lowest confidence actually has 3 items here on the left-hand side: long sleeve logo, jersey, and so on and so forth. And based on this one, 80% of the customers who actually bought those 3 items ended up buying a water bottle as well. Having a look at what this, the other numbers here are. So you can see this one is the support. Then this one is the confidence. So 100% of the customers who actually bought a Touring 2000 and a Touring tire tube ended up buying a Touring tire. Actually, makes sense, because if you buy a tire tube, you most likely would buy a tire as well. And yeah, here we can see another value or another measure, which is called lift of 24. So okay, we had a look at the rules and actually created all our rules. Let's think a little ahead. Okay, we now have rules based on the frequency set of all the items in our bike shop. The next question here would be, we want to have it implemented as a web service in Azure Machine Learning, because this is essentially one of the killer features of Azure Machine Learning as well. So for a web service, we need to have input and output. Input would be, yeah, okay, we have a new customer, and this customer bought item 1, 2, and 3. What else can we actually recommend to the customer? And with what probability would this customer actually buy the suggested or the recommended item? This means we actually have an input, which would be here in this case, the dataset 1. Let's have a look again at the dataset 1. Here in this case, our customer has already bought a Touring 3000 and a water bottle. Okay, then not necessarily. So this would be a CSV file, which we want to have as a vector because it's better readable as well. Here in this case, okay, I'll just run it for starters. This one here, this argument T of dataset 1, what it essentially does is something like a table or a matrix. So let's suppose this is in matrix form. This would just transpose it. Why would we want to do that? Well, we want to have the matrix in a vector, but row major. But if we don't transpose it, at first would go through all the columns, which is not our desire because it's row-based. So a customer would be one row. So we want to have all the preferences or all the things that customer one has bought first listed in the vector, and then the second customer, and so on and so forth. So we first transpose it and then just package it or repackage it as a vector. And this is what it essentially has done. Let's have a look again at the data set one. And we can see the same values as beforehand, just now in form of a vector. The next one just looks at what it essentially does is, let's have a closer look. It takes a subset of the rules that we have already collected or that we have calculated. Remember, we have about 219 rules. Out of those rules, it wants to see how often the data set 1, as in the two items, Turing 3000 and water bottle, was actually contained on the left-hand side of any rule. So this means we are looking for all the rules where on the left-hand side there are at least two items, and if there are only two items, it must be Turing 3000 and water bottle. It can also be a rule where on the left-hand side there are three items, but out of those three items there must be those two items, Turing 3000 and water bottle, and so on and so forth. So let's have a look at the rules match LHS. And it says, okay, there are a set of two rules. Let's have a look at those rules, actually. So we just inspect this again. And we see there's two rules. As I said, there's one rule where on the left-hand side there was Turing 3000 and water bottle. So exactly matching what the customer has actually done here in this case. And at a confidence of 1, so in 100% of the cases of the customers that have bought those two items, they also bought a road bottle cage. Let's have a look at the second rule. In the second rule, here we can see Turing 3000 and water bottle as well. And on top of this, those customers also have bought a Sport 100. And based on this, they also, in 100% of the cases, they bought a road bottle cage as well. So in any case, even if the customer decides to buy a Sport 100 on top of those two items, this customer always ends up buying a road bottle cage as well. And then in the end, output client, this is specific to Azure Machine Learning, because then we want to specifically say, okay, what exactly is it going to output? Running this one. And we can have a look at the output client as well. And this is what will be, well, outputted in this particular Azure ML experiment. We can see again those rules, Turing 3000 water bottle and leading to road bottle cage. So it's a, well, nicer view in this case. And then obviously the MAML output. So we've seen how to do this in RStudio. Now it's the next step, the second part of the demo, of transferring this script into Azure ML. Why would you want to do that? Well, to scale it, to deploy this as a web service. And this can be then easily integrated into a dashboard, into an app, into a website, and so on and so forth. So let's go into Azure Machine Learning Studio. I've already opened this or typed in the site studio.azureml.net and can see my workspace recommender. So for that one, I first want to create a new experiment. But before I do that, actually, I need to input or I need to import certain data sets as well. Remember, we need to first import the CSV file items basket because we need this frequent item sets file. And then on the other hand, we want to have some example input data. In this case, it was the Turing 3000 and the, I forgot, the the Turing 3000 and the water bottle. Just some example data set. So how we do that is we go onto New and click on Data Set, actually, from Local File. All these files have already been saved. One thing that I want to point out is this itemsbasket.csv file I have compressed in a zip file. This is actually necessary to do that because in the module execute R script that we are going to use to paste in our R script, it requires a zip or a script bundle. So before you import this data, first compress it into a zip file. I import that one then. Say, okay, itemsbasket.zip, or I'll just call it MVA beforehand, and import it. Now it's imported or uploaded. Another file that I want to upload is the example dataset, the Turing 3000 and the water bottle. You can actually upload any sort of data set as well. Here I called it R bike input. I'll just call it MVA beforehand as well. It's a generic CSV file with a header as well. So, okay. So both files have now been uploaded. Now it's time to actually create a new experiment. So again, new, and we want to start off with a blank experiment. Let me just call this collaborative filtering, and drag in some saved data sets. Here are my data sets, and we can see MVA R bike input CSV and MVA items basket. If we want to have a look at this one, just go on visualize, and we can see those two items, Turing 3000 and water bottle. So nothing new here. Then the next one that is of interest is, yeah, anything with R. So here we can see R language modules and see execute R script. If we have a closer look, it takes in 3 input input arguments. Dataset 1, which is this one, okay. Then a second dataset that could be useful here, and a script bundle. That was what I mentioned beforehand as well. So we just drag it in here. Then, okay, execute R script. This is where we can actually input or copy paste in our R script from RStudio. Let me go back to RStudio and to our data, to our R file. We can see here dataset 1 read CSV. Here in this case, we don't need to do that because this is already being done right here in dataset 1. So, okay, kick that one out. Here I can take items basket read CSV. The one thing that I need to point out is here I need to change it to source / itemsbasket.csv, just because it's reading from that script bundle. So I'll add this one, and then can pretty much copy paste some more of those arguments. I don't need to do the frequency plot. All I need to do is import or copy paste the rules, and then here specific to Azure ML, copy paste these ones in here as well. I can just delete these ones, delete this one as well, but I'll leave the last one, manual output port. The only thing that I actually am going to change here is change this one to output client, because it's here that I am going to specify exactly what is going to be outputted. So in this case, we are ready to run it. One thing that I forgot to change is obviously here, this needs to be changed to SRC, source, as in the case before, and yeah, otherwise it can't actually read the transactions. I run it again. And voila, it has finished running. Let's have a look at the output actually, just visualizing it. And we can see exactly what we've seen before in our studio, specific to Turing 3000 and Turing 3000 water bottle and Spot 100. Okay, so we've trained it now. We want to actually have it as a web service. So with the web service, all you need to do is actually get input and output. So input is pretty easy. All we need to do is just drag it in here and specify this one to be your input. Because here in this case, input, we just specify how, specify a new customer's buying preferences and seeing, okay, what else can we recommend based on the new customers' buying preferences as well as the preferences of all the other customers. As for the output, that's pretty easy. We can just output everything and drag it in here. And then let's just run it. This was pretty easy, or really quick actually. It's already, we can deploy this as a web service already. Let's take a step back. I mean, now we are actually outputting everything. What if we are actually interested only in the right-hand side? So in this case, we can use the module project columns similar to the previous module where we specified only the scored labels and scored probabilities. So here we insert project columns in between. We launch the column selector again, and we only want to have the right-hand side, as in the result or the right-hand side of the rule. What else we can recommend? We don't care about confidence or support. We only want to know what else we can recommend, and then let it run. Now we can deploy this as a web service. And since we have already deployed it as a web service beforehand, we can now overwrite it. So yes, we are going to overwrite that web service. And here we see, okay, we can test anything else with 2 items. So let's have a look what else we can actually use. Going back to items basket, let's say we want to do the mountain 200 and mountain bottle cage and run it, and then in the end some other recommendation can be made. And as expected, it has recommended a water bottle. Wrapping up this third module, what we've learned is we learned about association rules, about certain terminologies such as transactions, rules, confidence, and support. Then we've actually done a step-by-step demo in our studio first, based on some items frequency set of our AdventureWorks database. And then afterwards, after we've actually created our R script, we went on to scale it as a web service in Azure ML by first creating an experiment, training it using the R script that we've created before in our studio, and then publishing this as a web service. In the following, or in the next module, we are going to have a look at the other approach, which would be content-based filtering, and then extending it to a hybrid approach.